Okay, so I got a few questions yesterday during the Zoom meetings about trembling hand perfection, in particular how to solve the questions about the homework that I've given, and I wanted to provide a little more guidance about what trembling hand perfection is and what it does. So in the two examples that we saw, there was only one trembling hand perfect equilibrium for the game, but that doesn't always have to be the case. For instance, in this game, if you have these payoffs 1, 1, 1, 1, 1, 1, for instance, and zeros everywhere else, in this game there are three Nash equilibria: top left, center, middle, and bottom right, and each of those is trembling hand perfect. The idea behind trembling hand perfection is to consider the possibilities of error and thereby be able to rule out equilibria that don't make sense. So, for instance here, let's say we're playing bottom right. Even if player 1 plays top or middle with some possibility of, with some positive probability, bottom right is still, playing right is still optimal for player 2. And if player 2 is playing left or center with some probability, some positive probability, making some mistakes, even then, playing bottom is the best thing for player 1 to do. And so this equilibrium is trembling hand perfect. Just to concretize it, let's just add probabilities. Let's say this is P1, P2, and P3, such that P1 plus P2 plus P3 equals 1. Similarly, you're playing, actually it's easier if I put these probabilities on this side. P1, P2, and P3, Q1, Q2, and Q3. Then player 1's expected gain from playing T will just be equal to, so think of this as expected utility for player 1 from playing T. That is just going to be equal to Q1, this will be Q2, and this will be Q3. For player 2, similarly, this will be P1, P2, and P3. Right, and so even if P1 and P2 are some positive numbers, but they're really small, for player 2, as long as P3 is just really large, it's worthwhile to stick with playing R rather than L and C. So if, for instance, you're playing this with 98%, 1%, and 1% chance, it's still better for player 2 to best respond by playing R, and that's basically what you're doing with trembling hand perfect Nash equilibrium. The only equilibria that you get rid of are equilibria that you wouldn't play if there is some chance of a tremble. So it's possible to have more than one trembling hand perfect equilibrium. The other thing that I want to mention is that when we're considering only two-player games, and this is key, this is important, so if it's just a two-player game and not 3 players, not n players, then trembling hand perfection is equivalent to getting rid of weakly dominated strategies. So for instance, consider this. Let's say you had 0.5, 0.5. See, this is 0.1, 0.1. And here you have 1, 0, and 0, 1. Now, when we write out expected payoffs for player, this will, I need new markers. Now when we write out expected payoffs, for player 1 from playing T, player 1 gets Q1 by 2 plus Q2. This is just Q2 and this is 0.1 Q3. For player 2 it is from playing left, player 2 gets 0.5 P1 plus P2. From playing center, player 2 gets just P2, and from playing right, player 2 gets 0.1 P3. Now if you just look at Nash Equilibria, if you're just looking for Nash Equilibria, we look at best responses. Best response to player 2 playing L is for player 1 to play T, player 2 playing C is for player 1 to play this, and then similarly playing T, here. So you have 3 Nash Equilibria, and because M is weakly dominated by T, you can get rid of M. Also you see here, the working I would want you to show is that Q1 divided by 2 plus Q2 is higher than Q2, and therefore when Q1 is a positive number, player 1 is never going to play M. You can get rid of the Nash. So Nash Equilibria are TL, MC, and BR. But you can get rid of MC because player 1 would never play M because Q1 divided by 2 plus Q2 is greater than Q2. Another way, a different way to get, that's enough in itself to get rid of M, but also we can say that because 1/2 of P1 plus P2 is greater than P2, player 2 would never play C. So you don't necessarily need both of these to be 1. If this was a 0, you would still be able to get rid of MC as an equilibrium. You're not able to get rid of BR because BR is not weakly dominated. There's no way to show that this number is greater than this number, or that this number is greater than this number. So the 2 trembling hand perfect Nash Equilibria will be TL and BR. Okay, so hope this helps, and even in case you've already submitted your homework, I think you should still look at this and make changes if needed. I hope this adds a bit of clarity.